Hi, I'm Rajiv from group B16 and I'm going to talk about the Handshake theorem. The theorem states that the sum of the degrees of all the vertices in the graph is equal to 2 times the number of edges in the graph. Before looking more closely at the Handshake theorem, I'd like to talk about what the degree of a vertex is. The degree of any given vertex is equal to the number of incident edges where a loop is counted as 2. For example, on the left graph here, the degree of A is equal to 1 because we have one incident edge. The degree of B, on the other hand, is 3 because we have 3 incident edges. One right here, a second one here, and a third one here. Now, looking at the second graph, the degree of B is 4 because we have one edge here, a second edge here, and then a loop right here. And the loop is counted as 3, so the total degree of vertex B is 4. Going back to the Handshake theorem, it states that the sum of the degrees of all the vertices in a graph is equal to 2 times the number of edges. To prove this, we count the number of vertex edge incidences twice. First, we can count it as the sum of the degrees of all the vertices in the graph. That just follows from the definition of the degree of a vertex, because for vertex A, for example, we have a degree of 1 and 1 vertex edge incidence. Another way to count this is by looking at the number of edges. If we look at the edge between C and B, we can see that this one edge contributes 2 vertex edge incidences, one here and one here. So we can say in total that the total number of vertex edge incidences is 2 times the number of edges. One application of the concepts shown in the Handshake theorem proof is for bipartite graphs. For example, sexual relations or sexual partners between males and females. In this case, we're going to assume only heterosexual relationships. Let's say in a study that we found that males on average have about 5% more female partners than female partners have male partners. We can write this out as the sum of the degrees of the male vertices divided by the number of males, and right here we have that is the average number of partners that each male has. Because if we look at, say, this vertex right here, this guy has 1 partner. So based on our given that males have 5% more partners, we can say that this right here is equal to 1.5 times the sum of the degrees of female vertices divided by the number of females. Now, when we were doing the proof of the Handshake theorem, we saw that each edge contributes 2 vertex edge incidences. Looking at this graph, we can see that each edge contributes 1 to the total degree of male vertices and 1 to the sum of the degree of female vertices. Therefore, both of these two quantities right here have to be equal. We can divide both sides of the equation by those summations, and we get 1 divided by the number of males is equal to 1.05 divided by the number of females. Oops, sorry about that. So, based on this, we can conclude that the number of females divided by the number of males, or the female to male ratio, is equal to 1.05. It's kind of crazy that we can find a gender ratio just by looking at the number of partners. Thanks for listening to this video about the Handshake theorem.